Welcome to Chemistry with Caroline. In this video, we're going to look at how to name alkenes. So alkenes are compounds that contain double bonds, and the carbon-carbon double bond is a higher priority than an alkane or a halogen. So those are the things that you probably know how to name from before, so X being a halogen. So because it has a higher priority, you're going to number to give the alkene the lowest number possible. So I'm still going to find the longest chain. I have to start from an end, but I can start from the left-hand side or the right-hand side. And if I start from the left-hand side and number 1, 2, 3, 4, 5, and 6, then I would get a 2 locant for my double bond. If I had started on the right-hand side, however, the locant that I would get would be a 4. So we want to give it priority. So we're going to start from the left-hand side so that it has a locant of 2. And then you just name it like you normally would, but the end name is going to be modified with -ene instead of -ane. So I have one substituent, this methyl group, and substituents go out in front. So it would say 2-methyl. And then I can put the locant either out in front of the parent chain name or actually right before the modifier. So I'll show you both ways. But one way is to say 2-hexene. So the -ene tells me that I have a double bond, and the 2 is the locant. It tells me where the double bond is. Double bonds stretch over 2 atoms, but you always use the lowest number as the locant to indicate its spot. So let's look at another example here. This time we're going to have stereochemistry associated with a double bond that we'll need to indicate. Again, we number to give the double bond the lowest locant possible. If I start numbering from the right-hand side, I'll bump into the double bond first versus the left-hand side. So I'm going to number from that side. So my double bond is going to have a 3 locant, and then I have 2 bromines on my chain that will be substituents. But I also have a double bond where each side of the double bond has different groups on it. And so that's going to give me stereochemistry. So on the right-hand side of the double bond, I have a bromine versus a carbon, carbon 2. Bromine has a higher atomic number, so it would be the 1 priority, and the carbon would be the 2. On carbon 4 in my double bond, I've got a carbon, carbon 5, and then a hydrogen that's not drawn. The carbon has the higher atomic number, and so the hydrogen would get the lower one at 2. My 1s are on the same side, so the stereochemistry for this is going to be Z. So remember, stereochemistry goes all the way out in front. My double bond is at the 3 position, so I would write 3Z in parentheses, much like we would indicate a chiral carbon with an R or an S and a locant attached to it as well. Then my substituents would come in alphabetical order, and so this would be a 3,5-dibromo. Di because I have 2 bromos, 3,5 because that's the location where they are. And this time I'm going to put the locant for the double bond directly before it so we can see the other way that you can name. So this would be a hept3-ene. So again, the -ene tells me that I have a double bond, and this time I've placed the locant directly before the -ene. So you can put the locant before the whole parent name, directly before it, or you can put it right before the modifier where you change -ane to -ene. So we'll look at one last example. In this case, I have a cyclic compound and also a compound that has more than one double bond. So on a ring, there is no end, so you can start wherever you want. So you'll always start at an alkene if there is one, because that's going to be the highest priority. So I would start at either one, and you're always going to number across the double bond. In this case, the top alkene has substituents, so I could also give my substituents lower numbers in this process. And so I would number in this order. So I go across alkene 1, 1, 2, and then get to alkene 2, and that would be 3, 4. So this guy has 2 substituents on it, 2 methyls. So this would be a 1,2-dimethyl. And then it would be 1,3-cyclohexadiene. Or I could have named the parent cyclohexa-1,3-diene. So again, where I put the locants directly before the modifier. Now, there's a couple things going on here. Again, you have your locants, regardless of which place you put them. So that tells you where your double bonds are on the molecule and relative to one another. 2, when we have more than one double bond, we had add this here. So it's not hex 1,3-diene, it's hexa 1,3-diene. So when you have more than one double bond, whether it's 2, 3, 4, however many, there's always another A there. And then again, I'm going to have di, just like I would for a substituent that I had 2 of. If I have 2 double bonds, I need a di prefix before the modifier, which is this -ene part. So di tells me that I have 2, -ene tells me that I have double bonds. The locants 1 and 3 tell me where they are. And then just sort of for like a flow thing, I think we add this A here, but that's how you'll see it anytime there's a molecule that has more than one double bond. You'll notice that I didn't do stereochemistry here, even though the double bonds do have unique groups on them. In cyclic systems, we tend to not do stereochemistry because the conformation of the molecule is such that it has to be in a specific orientation to be connected. So you don't have to worry about noting something as E or Z when it's a double bond that's inside of a cyclic compound. So this has been a look at how to name alkenes. If you found this video helpful, please like, subscribe, and share with your friends.